Greetings. I am Professor Yong Vimon Lenberry, Director of the Center of Excellence in Mathematics under the Science and Technology, Postgraduate Education and Research Development Office, Ministry of Higher Education, Science, Research, and Innovation. I'd like to take this opportunity to provide you with some information about our research effort on COVID-19 and the impact of lockdown measures on the Thai economy. A research team of the Center of Excellence in Mathematics has been carrying out research on modeling of COVID-19 to forecast new cases and the impact of lockdowns and easing strategies on Thai economy. By using dynamic models to gain insights leading to valuable recommendations to decision makers on the strategies to be adopted to cope with the pandemic. The models track the number of mobile humans during lockdown or easing periods, and the number of weekly new cases infected by COVID-19. We use gross national product per capita or GDP as the indicator of economic health. The initial value of GDP that we used in our model simulation is $6,419.75, which has been reduced from $7,792 per capita before pandemic. The initial number of cumulative cases used in our simulation is 2,947 cases, which was the data at 29th of April, 2020. The removal rate used in our model is 0.21555. This is the rate of infection due to the interaction among humans, which has been calculated from reported data during lockdown. The factors which we considered in constructing the model are the rate of business or opportunity loss due to reduced mobility, the effect of mobility, which contributes to business growth, the rate of business stimulation from aliens, and delays in becoming symptomatic, which is approximately 2 weeks, which is denoted by tau nu in our model, and the delay in business recovery, tau b, as well as the delay in business recovery connected to aliens entries, tau f. We use our model to simulate the case in scenario 1, in which we suppose that it is 8 weeks before business will start to recover and is felt by the increase in GDP. And the lockdown was carried out for 9 weeks, and it is eased and relaxed and the business is open up 9 weeks. The aliens are quarantined for 2 weeks and no infection was detected. The delay in stimulation of business due to aliens' entries is 3 weeks in this scenario. The result of the model simulation is shown in this graph. The first one shows the number of weekly new cases. We see that when the lockdown is eased up, the number of new cases will increase until it reaches the level of a little bit over 1,000 new cases per week. And then it stays above this level, increasing a little bit for 5 weeks before we start the lockdown again. And the number of new cases will drop. Okay. And we carry out the lockdown for 9 weeks before we open it up again. So the new cases will rise again. The number of cumulative cases will increase, okay, until it reaches the level of approximately 14,000 cases in 32 weeks from the beginning of our model simulation, which was started 2 weeks before the easing of lockdown begins. And we carry out the simulation for 32 weeks. If we look at the graph of GDP per capita, we see that its level will increase a little bit when we ease the lockdown, but it will not reach the level of the original level before the lockdown. And since the number of new cases has reached a very high level, we have to start the lockdown again. And so GDP will decrease again, and it becomes lower and lower. And there seems to be no possibility of business recovery to reach the level that we had before the pandemic started. Now we carried out simulation again for another scenario, scenario 2, in which we then assumed that the business recovery takes 7 weeks to be felt by the increase of GDP. And we carried out 9 weeks of lockdown and 9 weeks of opening of the lockdown. However, in this case, in relaxing the lockdown, we simulate the case when the easing up of the economy and the business is done gradually, bit by bit. So some of the business would be allowed to open up, but not all of them, gradually allowing some of them to open up, and then more of them gradually, in a gradual fashion. Again, the aliens are quarantined for 2 weeks, and we assume that there is no infection. Tau F is still 3. We see that the number of new cases increases to a level above 1,000 new cases per week for just 3 weeks. Because the relaxing of the lockdown is done more gradually. So the cumulative cases will increase to a level that is lower than in the previous scenario. Only 10,000 cases after 32 weeks. While the GDP will increase to a level that is almost equal to the level before the pandemic started, a little bit lower than that level. So our simulations suggest that if the delay before the business can recover is smaller, business recovery is then possible, but not to the same level as before. And also, more gradual easing of the lockdown leads to less cumulative cases. In scenario 3, we suppose that business can recover faster, provided that the government put up a huge bailout scheme to help the businesses to recover faster. Then we see that we do not have to relax the lockdown for very long, because the business does not take that long to recover. Okay, so we try just lock down for 9 weeks and open and relax the lockdown for only 6 weeks, so that the number of new cases, once it reaches this high level of something above 10,000 new cases, we make a sharp lockdown after 6 weeks. So if the business can recover faster, then we can lock down faster to keep the cumulative cases at a low level. After 32 weeks, the number of cumulative cases is a little bit higher than 8,000 cases, which is lower than the previous 2 scenarios. While the GDP increases after we relax and ease up the lockdown and then close it up again and relax the lockdown again, the business recovers so that GDP reaches level seem to be more or less the same as the level that we had before the COVID-19 crisis. The result of these simulations then suggests that substantial bailout scheme can yield shorter delay before business can recover, so that we can lock down faster, yielding lower cumulative cases, and business recovery is still possible. Then we consider the possibility that when we relax and ease up the lockdown, we would allow some of foreigners, travelers, tourists, and foreign businessmen would then travel back into Thailand. And they could bring in people that are already infected. And when they enter Thailand, then they can potentially infect the population of Thailand in the country. And so we modified the model to take into account this possibility. And so in this modified model, we use the infection rate of RI equal to 0.16444, which has been obtained by fitting our model to observed data, so that the model will yield 42 new cases, which was reported between 30th of April to the 6th of May. So once we fit our model so that we can get these 42 new cases in this week, then we use our model to check for its accuracy. We simulated the model and we found that it predicts that during the week from the 7th of May to the 13th of May, there would be 27.77 cases, new cases during that week. And once we got to the 13th of May, it was reported that there were 28 new cases during that week, actually. And so our model performed quite well. And the accuracy is quite good. So we used our model to simulate scenario 4, in which we still assume that the delay in business recovery is 3 weeks. And we also incorporated the number of infected cases that have recovered using 4 weeks before they recover and return to the population that can interact with each other. Also, when the government eases up the lockdown, the international flights might not be allowed in to the country. Yet, from the very beginning of the easing of the lockdown, international flights may be delayed for N weeks after ease of lockdown begins. Also, we tried this case in which aliens are quarantined for 2 weeks. However, after the 2 weeks, 10 out of 10,000 is infected, leading to 6 infected in 2 weeks, and 1 person 1 week after the release week. The result of the simulation is seen in these graphs. The number of new cases rises to a very high peak, of course, because now we incorporate the fact that aliens, tourists, travelers from abroad can bring in infected people that will in turn possibly infect the people inside the country. Therefore, the number of new cases show quite a high peak. At the highest peak, it reaches the level of 2,000 new cases per week, while the GDP gradually rises to a level which is still lower than the original level before COVID-19 started. This is the case where the international flights are delayed for 4 weeks after the easing of lockdown began. And the lockdown was carried out for 9 weeks and it's opened up for 9 weeks. Okay. Now we look at another scenario in which the delay of allowing international flights to land in the country is 3 weeks instead of 4 weeks. Still locking down for 9 weeks and opening up for 9 weeks. We see the green curve is the graph of this scenario. The green curve for the weekly new cases reaches a higher peak from before because we allow in the international flights bringing in tourists and aliens 1 week earlier. So the number of new cases starts to increase here 1 week earlier, here and here. Okay, so the number of cumulative cases also becomes higher. On the other hand, the GDP starts to increase after the ease up of the lockdown 1 week earlier because we allow the international flights and the tourists and the international businessmen and people that want to come in to do business in our country. We allowed that 1 week earlier. So you see that the GDP will rise due to this stimulation by tourists and foreign visitors. Okay. So it will rise earlier and reaches a higher level. After lockdown and opening up the second time, it will reach a little bit higher level, almost reaching the same level as before, but not quite. Okay. Now, the next scenario is when we assume that the delay in allowing the international flights to land in our country. It's still 3 weeks after the first day of the lockdown, of the opening, easing up of the lockdown. But now, the second time we lock down is only 7 weeks. Instead of 4 weeks, we lock down again, only 7 weeks. If we lock down by doing it very sharply, it's called sharp lockdown. If we do a sharp lockdown, which means that we don't just gradually, bit by bit, allowing some business to still be open and close down some of the business, and then we gradually close down more businesses, and then gradually more businesses are closed down. If we do it gradually, lock down, then the number of new cases will not decrease sharply. There will be some new cases, so that we cannot ease up the lockdown yet because the number of new cases is still not very low. But if we do a sharp lockdown, we take down the number of new cases per week sharply, and then it stays low for many weeks already, as you see here. So we can ease up the lockdown earlier according to this purple curve, see? So the number of new cases using this purple curve, see, will reach a level more or less the same as the first scenario, the first case, about 2,000 cases per week. But the GDP will rise fast, will rise up earlier. So our business and economy will recover faster if we carry out sharp lockdown and then bring down the number of new cases to very low quickly. And then we can ease up the lockdown faster, and our business and economy will be able to recover faster. Then we use our model to simulate another case in which the delay in allowing international flights to land is still 3 weeks. We do a 9-week easing of the lockdown, but the next time we do a lockdown, we do it for a shorter period of only 7 weeks. We also assume no delays in business stimulation by foreign visitors or aliens. Moreover, we suggest a stratified entry strategy and selective entry strategy, which means that we allow first only those tourists or foreign visitors from countries that has successfully controlled their COVID-19 situation and has brought down the number of new cases to satisfactory low levels. Also, we would allow in only visitors that wish not to go to places where it's very crowded and very risky in creating new infections, so that social distancing can be carried out. If they wish to go to nightclubs or pubs or to watch Thai boxing, then they're not allowed in yet. And the businesses that we allow to open up and operate would be those that respond to the wishes of the foreign visitors. For example, the tourism business that will take the foreigners to remote places, such as to seaside resorts or into the villages, remote areas where it's not crowded, then they would be allowed to open up first. Also, we suggest that we don't allow a whole number of foreign visitors to enter at the level before the COVID-19 situation. Before the crisis, we might be able to accept the entry of a lot of visitors from abroad in a day. But we suggest that we gradually open up and allow the number of visitors from abroad to reach only approximately 50% of our capacity that we were able to allow in before the COVID-19 crisis. If we do that, then the result would be described by the blue curve, whose peak reaches a level that is noticeably lower than the two previous cases. Only about approximately 1,400 cases per week at the highest peak, which is approximately 200 cases a day. And GDP will follow the blue curve that is seen here. Okay? It will reach a level that is not very high at first, but if we do this for approximately 1 year, then we see that the GDP will gradually grow until it reaches a level that is close to the original level of GDP that we had before COVID-19. Now, we have used our model to predict the number of new cases each week. I have already mentioned that during the week from the 7th of May to the 13th of May, our model predicted that there would be 27.77 new cases that week. And when the 13th of May rolled around, we found that the actual number of new cases that week was 28 cases, which is quite accurate, close to our prediction. We also used our model to predict the new cases in the week after that, between the 14th of May to the 20th of May. The prediction was that there would be 17.14 new cases that week. And when the 20th of May rolled around, the actual number that week was 17 cases. So the accuracy is very satisfactory. We did the prediction 1 week after that as well. Between the 21st of May to the 27th of May, the prediction was that there would be 21.37 new cases. The actual reported new cases that week was 20 new cases. So the discrepancies between the reported case and the predicted case is still acceptable. We also predict forward to the week between the 28th of May and the 2nd of June, which has not arrived yet while I'm doing this video. The prediction is that there would be 34.7 new cases, and we still have to wait for the report to come out, whether this prediction is accurate and how accurate it is. The prediction for the week after that, between the 3rd of June to the 9th of June, is that there would be 136.1 new cases. And you see that the number has risen sharply from the previous week of 34.7, because we have opened up the economy and foreign visitors have started to roll in. So there would be a few weeks delay before infection can be detected. And it shows in the number, in the high number in this week, between the 3rd of June and the 9th of June. This is provided that the conditions and strategies or policies adopted by the government in easing the lockdown are as announced, and those are the conditions that we use to construct and simulate our model. If those policies are changed, for example, if the easing of the lockdown becomes more strict or less strict, then we have to modify our model accordingly. And the numbers predicted will change. We also assumed that we did a sharp lockdown so that only shorter lockdown is necessary. Also, the model assumed that there would be substantial bailout scheme provided by the government to help the business to recover faster. If there is no substantial bailout scheme or support from the government to help the small business or the medium-sized business to recover, then the curve of GDP would be different from what we have reported, because the startup curve of the businesses would not be so steep. Also, we need strict quarantine and strict tracking and tracing system. We also suggested that we do a selective business opening, as well as selective foreign entries, and only half of our capacity. Recovery will be rather slow because our business depends too much on tourism, but complete recovery is possible in approximately 1 year. In closing, we hope that our research effort can be of some valuable assistance to those who have to make a decision on the policies or strategies to be adopted to cope with the current situation of COVID-19 pandemic.